out at CEN, where the terracotta soldiers are, there was, my wife and I found a cone threshing cylinder, which was made out of brick and concrete. And the concave is down here at the bottom, like Amir Khan put in. What I was doing at the time I was doing it is I had the whole screen system was a screen that anywhere a kernel is liberated and goes out to the periphery of the cone, it goes through the cone, but here it is carried on around, and that's okay. I think it got plenty of time, so that's okay. Here is the 1977 International Harvester. Roland Hill came out with, no, not Roland, Murray. Murray came out with this. Roland Hill had come out with the New Holland one in 1975. And so we had two rotaries on the market then. John Deere came out in 1997 with their cone. Another thing that I did, I was wanting to try to increase the amount of power that was available to the farmers. And so I hooked together two tractors and made what I called a tandem tractor. And this is E.V. Collins here, my major professor, driving the first set of full tandem tractor that was built. This was tested and when I hooked together a two-bottom plow tractor, a two-bottom plow tractor, and I put a six-bottom plow on behind it. Farmers wanted to fight me. You can't pull that. I said, yes, I can. And what it shows out is that you could get 50% more power from a tandem tractor than you could from a single two-wheel drive tractor. And there have been companies building four-wheel drive tractors, but they had tested them at Nebraska, and you could show no improvement on efficiency or anything on a concrete track. But when you found out you had the front wheels, I call them John the Baptist wheels, that go and compact the track, make a track, and then the rear wheels work out on it. And you put this tractor in second gear, and you put this tractor in third gear. And you not only pull 50% more load, but you pull it faster. And that's what we taught there. I call it tandem addition, is 2 plus 2 equals 6 plus. And this was learned by industry. E.V. Collins got a hold of C.B. Ritchie, and Ritchie he made a tandem tractor after I left Iowa State, and went up to Michigan State, and so he made his own tandem tractor. And when he became so impressed with it, that he started going to the farm machinery companies that were building tractors and telling them that he would like to talk to them about building four-wheel drives. And they said, oh, just wait a minute. And they took him out to the research shop, and every one of the companies was building a four-wheel drive tractor in the research tractor shop when he came up there to talk them into building four-wheel drive tractors. So he accomplished everything there. This is C.B. Ritchie's testing E.V. Collins' tractor that he built. Now, this is the Swedish tractors, and been tandemized, and then eventually we came to the four-wheel drive tractors, and they're used today. The forage harvesters, we have been trying to develop biomass, and this is Tom Hightank's, no, not, huh?
Hi, Susan.
Hi, Susan. I got that. I'm like the Texan governor. They need somebody to keep me straight. And this is taking a conventional two-row forage harvester and then putting a shelling cylinder right in between the two of them and elevating the ear corn up after you have snapped it, and then putting it on a sheller and shelling it, and the cobs come down and come out of here, and the cobs come out of here with the forage, and then the grain would come out of here, and so we have this situation here, and here is the going there, and here's the forage here, and the grain is here. And unfortunately, this is not cut on. It is still, we're throwing, 50% of the nutrients produced by a corn plant is in the stalk. And so farmers harvesting nutrients harvest 55% of the nutrients in grain, and then they dispose of 45% of the nutrients. Now we have biomass harvesting, and maybe we will eventually not only save the loss of the nutrients that we're losing now by making them into a fuel source, but also increase the productivity of the farmers. And I one time gave a paper on the breakdown of things and shows that what would you do if you could take the corn stalks off the field and use them for various things, and this is what you would have, is 3,000 pounds that would be available for feeding your cows or for selling off as an energy source. But you need to leave 2,000 pounds on the field to keep the soil from blowing away and washing away by water. And then we have drying of corn and heating the house and the farmhouse and feeding the livestock as a use for the corn stalks, which we were not using at all. One of the things that I found as I conducted research is that you're no smarter than your instruments. And so I've built a number of instruments that, as I conducted research, and this is the first undisturbed core sampler. We plow the soil, we till the soil and everything else, but we don't know what we do with it. And this allowed us to dig down 16 inches, get down into the subsoil and weigh the cores and build a graph on a 16 inches on 2-inch cores. You could have 8 points. So, and 8 points give you a good story of what the soil is at that particular moment. And so here it is in the ground. The gearing is all the way up in here. You hold this electric geo stationary, but the thing goes around and around and digs it and works. And then we could cut it, bring it over and cut it up. And here it is, you're shearing it. We have a 2-inch high spacers here, rings, and you could plot from that your graph that you needed. And we were, at that time, in 1951, our soils were washing away. We were washing deep ditches in the fields. We had 50 tons per acre loss of soil from a rain, and the Secretary of Agriculture, Hugh Bennett, right now, who started soil conservation right here, telling you we were losing over 3 billion tons of soil, and that went right on up to 6 billion tons, and then it dipped over there, and finally it is coming down, and I don't know where it is around there. The Secretary of Agriculture aren't making any prophecies now, but anyhow, this was the condition in 1951, and we had dust storms. We had a lot of dust storms, and the ditches filled up with topsoil, And the highway department, when they needed topsoil, they just come out and cleaned up the ditches. And they didn't pay the farmer a thing for that land, the soil that they got. And so one of the things I did when I went to Iowa State is that E.V. Collins had a brainstorm of starting a ridge-till system of farming. And he asked me to join his team, and so I gave up working on the cone thresher and began working with him and Walt Lovely on a ridge-till system of conservation farming. And incidentally, I invented that word. We were going to have a conference. I've been trying to get these soil conservationists, which we have in each county, to pay attention to our ridge-till. And they wouldn't pay any attention at all. And so I publicized we were going to have a conference on conservation tillage, and they woke up. What's that? And so they came to the meeting, and then they got on board and started to saying that tillage is a way to, a tillage system will save your soil just as well as it will destroy your soil. And so we had ridge till, and now eventually we have, we were doing that with no-till, and eventually no-till came in which you did nothing except spray, and using the Maxi-Merge planter, which Ron Brass developed, allows us to have a major system of farming that farmers are now using today. Well, to go back to ridge till, this is a ridge till, furrows here about 8 inches below the top of the ridge. Here it is planted, and the crop residue is down in here. There's no tillage been done on this till planting time, and then you grow the crop of corn, and this has been bully-worked with a combine, and the crop residue ends up here. And then Walt Lovely and others run tests with a rainmaker, and here it is on different slopes. Running the tests, I said, well, why don't you roll these rows around the hill? You don't give us the right answer because all you're doing is this. Well, sometimes we have a little slope in our furrows, and we should know what kind of losses we get. Well, so, okay, well, we did it. And we caught the water and from the different plots and found out what we were doing. And so here's the data. This is ridge till, and this is till plant, and conventional farming. And this was a 2-inch rain over an hour, 2 hours, and here is 40 tons of soil. And here, with the ridge till, we can eliminate the effective slope on the loss of soil. This is the way the soils, this was a good seed bed in 1950. It had been plowed, had been disked 3 times, it had been furrowed. It's ready for planting. No, it is. It's ready for plowing again. And so here you see the tracks in the field, and that was the state that was. And this is a picture my brother took, a farm in Kansas where I grew up. And this had been plowed, and then they tandem disked it this way. And these are the tractor tracks of the tandem disc. And then they disked it another way. And here you can see the disc marks on the compacted soil that you had created with your tars. And so when you run through a field, you leave tracks. And they're underneath, they're invisible. You may plow, disc them out and so forth, but they're there. And this, people do not understand what it is. So I applaud when we use Ron Brass's Maxi-Merge on 24 rows at a time or 32 rows or so forth, that you're doing less compaction and less compaction.